back in the shack, I thought I'd play with some stuff. I got in the mail the other day a plate transformer that I bought from a gentleman, and I thought I would cover some basics of their construction and how they work, how to measure the voltage and their design and so forth. And this is a mystery transformer. And when you get a transformer, it's got this kind of label on it. You got to kind of question what you got. I've hooked this up a couple times now and run it, and had to do some stuff. When it showed up here, the spacer plates that go between the windings and the core body down in here had come out in transit, and the base plate had busted off on one side. So the transformer was dangling, hanging by one bolt, and these plates were floating around inside the box. So I reattached the base, put a new bolt in it, which means my banding is now a little bit loose. Unfortunately, that's just the way it is. And short of cutting the banding off and retightening the banding, this thing's gonna hum. So I figured, well, what the hell? I mean, this thing's a little bit beat up, but should get the job done for what I'm gonna use her for. I'm gonna use this to power a driver for another amplifier I'm getting ready to build as my big box, or as a tube tester, I guess would be the best way to put it. But this will serve beautifully as a driver. When I first plugged it in, like just said, there was no spacings in there, and you could see the two coils they'd charge, and they'd suck apart, or one would shift over and the other one would It's amazing amount of eddy magnetic current that takes place inside these things. But what I did is I ended up taking two pieces of hardened black, not plastic, but fiberglass like this, two pieces of it, and running it down on the edge of the coil against the core to push the coil apart. And I did the same thing on this side, as you can see, to keep it from humming too awful bad. These coils have been beat around so much that the wrap inside of them is now a little bit loose. Now, the two things that will make a transformer hum: one, poor design. Well, not two, three things. The second thing is that your windings are loose, and the third thing is that your plates that make up your core have delaminated or don't have enough pressure on them to hold them together. And everything here makes a difference. How far apart these are spaced. Oh, you scratched that there, Momo. I got the dog out here with me today. How far out these are spaced, the placement of the coil against the core, all of it makes a difference in its operation. Now, they claim that this is 3600 volts at 2 amps, which is perfect. 3600 volts at 2 amps is just about where I want to be, because I need to build up a 3000 to drive something else, and I want it to loaf the 3000. I don't want to really jam on it. So it's not like we're going to put 5000, 6000 volts on that 3000 and then put some bias on it to get it to really scream. We're just going to loaf it, and this will be perfect. So I got this transformer for a little bit more than I should have, but I wasn't willing to wait to get another one, so I just went ahead and I got this. And it's seen some hard times. We're going to cover this one, an actual data tag labeled Peter Dahl at 3 amp, actual Peter Dahl labeled 1.5 amp at 3000 volts, and then this little guy right here, which comes from my friends Michelle and Peter there at Electronic Product Design. Let me hold static on that for a second. The actual printed data numbers. Non-printed, but this isn't a fixed. This is a fixed primary, fixed secondary, where this is a changeable primary, which is on this side, or changeable primary and secondary on this side, which is changeable. So the same thing here. Fixed secondary, but floatable primary. And these plates were an afterthought. These aren't stock. These two terminals are a little bit too close together. There's going to be a lot of me putting the camera down, because to turn power on and off for this, it's a little ways away for safety reasons. If anything arcs or anything, I want it to happen over here away from me. But there are going to be some extreme voltages on this workbench today. We're going to go all the way out to 5,200 volts pre-rectified. on this transformer. And we're going to try and do this in a fairly quiet environment so you can hear the different transformers humming. Let's go over the type of cores. This would be either an L core or a U core. There's so much paint on it that I can't tell. Where this is an E core, a double E core, and you can tell by, it's not showing up too well, but you can see the stacks in the laminate. They converge here, like here. This is the stacks in the laminate. And the core body shape is, looks like two E's, and these are held together by bands. You'll find that most like neon transformers or microwave transformers or anything like that are what they call an IE transformer, and they're welded together. When you get bigger up in the iron, this is different. You got to band it. It's kind of hard to weld it. And then if you get down here and you look real close, you'll see that the laminate design for the core on this is a staggered connection. So as they build the core up and they're laying down the plates, each plate gets progressively longer in a series of, like, what is it, 5 or 6? And this is the trick to making the transformer super efficient. One of the tricks of making this transformer super efficient and really quiet. That and high quality banding and a really, really incredibly tight wrap. And not relying on paint to keep everything tight. But this is set into a vacuum tub, brought down to 0, and all the coatings on this were impermeated permanently inside of this thing. This is a beautiful transformer. This is $1,700, I believe, before shipping, for just this one little transformer. And I say little. I'm 6'5", weigh 300 pounds, and I had a hard time getting it up on the bench by myself, and I've got it sitting right here underneath the edge of one of my primary bench supports. I've got one bigger from these guys that I bought from somebody else. They made me a hell of a deal on it, and it has eye bolts on the top of it so you can hook it to an engine hoist to move it around. That will be the plate transformer for my next big tube tester that, as we all know, will be able to run easily out to a 20. But this is for another project. This is going to be a neat one. Can't wait to build that box out sometime next year. When I get around to it, it's for me, so I'm not on a timeline crunch for it like I'm everything else. But yeah, let's get on with this. It's gonna be fun. I don't know if that's translating to the phone or not, but it's humming. So just listen for a second. This transformer's in a state of flux. Now, we're going to use a reduction probe. We've got this set on AC setting, and we're going to look at our common, which is common 230, 240, 250. We're going to probe that. Now, because the transformer's in a state of flux, or working, there's a little bit of ambient eddy currents that are coming off the transformer, and it's getting into my probe. And it's showing that we have 200 on the primary input. Remember, this transformer's live. And as the current's stacking up and then transferring to the next coil, the coils are able to move a little bit. And so is the core, just a tiny little bit, because remember I said that bolt was broken? And that's what we can hear humming. I'll put the phone right onto it. Now, when dealing with high voltage, you are playing with the devil. Respect it, and you won't die. It's not a, you respect it and it respects you. No, it doesn't give a crap about you. It doesn't care about you. It doesn't care about your kids, your family, your job, your life, anything. It's just present. And it will kill you deader than a post. And there is significant current here today on this workbench. These are big boy transformers. There are bigger ones out there. Not saying that these are the biggest, but there's enough here to kill you. And my wife, at 10-minute intervals, I can't find a setting in this thing to change that up. My wife knows if she comes out here and finds me flopping on the floor, don't even come and try and touch me. Go over to the panel and shut all the power off for everything out here first. It's very important that if you work with this, that you have the proper kind of equipment, the proper kind of training. I'm an ex-power lineman, so to be around this little low current of 3,000 and 4,000 volts is nothing when I'm used to hot gloving 14,700. And then hot sticking on up to 28. And then I did aerial work off the side of a helicopter on 120 and 240,000 volts transmission. So this stuff doesn't scare me, but God knows I've got a very, 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 very deep respect for it, and so should you. Can't stress that enough. Respect this or it will kill you, and there's no second chances. None. So I'm standing here talking to you, I got my hand in one of my pockets. It's a habit. It's a habit to get into. As you see, as we'll go through this, my wedding ring's off, my metal watch is off. I kind of like my finger, I kind of like my hands. Okay, safety lesson over. So now you can go and you can take your 10-to-1 reduction probe and you can hook it up directly to your two terminals here on your secondary. Primary's input, secondary's output. And let's cover that. So when you guys call up electronic product design and say, hey, Peter and Michelle, I need transformer, and they're going to say to you, well, what's your primary and what's your secondary? So you're not sounding like a complete oaf if you don't know anything about it and you're trying to get yourself one of these transformers. Primary, secondary. Space is your only insulator here. When I go to put the probe onto the transformer, the distance of the probe, the surface area of the probe, and the non-conductive material it's made up out of is what is keeping me from death. My hand is a good foot away from this thing at all times. And that's just the way I want to keep it. So I keep making these crazy videos. So like I was saying, you can take the probe and you can hook it up to the two secondary leads. Or you can do a sum total measurement. We're going to do a sum total measurement on all of these. And it's going to get us relatively close. So we're going to take our test lead, go to our secondary, and that's showing us 1,659. So we're going to take 1,659 plus our second secondary tap, 2,043 plus 2,043. No, not plus minus, not to the second negative. 43 equals 3,702 volts. Now remember, this is giving me about 80 volts worth of plus current. Let's see what this is labeled at. 3,600 volts. And that's on the high common or primary. 230. So we're pretty close. We'll see if this is 2-amp regulated or not. I'm going to go throw it in something and give it a test drive and see what we get out of it. Let's get on to the next transformer. This will work. Let me show you what we got going on next. Leave the phone on the workbench just for a minute. The camera on the workbench, I mean. We're on our second transformer. That other little guy's gone. I moved him off the workbench, so we got a little bit more room to move around safely. We're on the actual labeled Peter dahl. And the reason this is important is that just because it's black and it's got red fiberglass on it does not necessarily mean that it is a Peter dahl. Peter dahl. I have a feeling that this is an original Peter dahl. Come on, autofocus, here we go. This is original Peter dahl, and this is a secondary Peter dahl. The Peter dahl company has been bought and sold a couple times. I do believe it's now currently in Harbach's hands. I had the opportunity to buy Peter dahl, a transform company. It came up a couple years back, and I wasn't in the money position, nor did I want to take it on. If I went to go work anywhere, I'd go work for these guys. I love Peter and Michelle. They've taken such good care of me. I've learned so much from Peter. He is a brilliant, brilliant man. When you call somebody on the phone that runs a big multi-million-dollar business, right? And you get with them on the phone for a little bit, and they will spend hours on the phone talking a problem through with you or a design issue with you. And they can build you anything. They're totally flexible. Tell them what you're looking for, primary and secondary, and they will design anything for you. Got to order these out of a catalog, but these come from a long line of, well, when this guy was designing them himself. Just saying. All right. Let's grab our little probe, 10 to 1. Check our primary, 248 volts. Now that's how electrically noisy that other transformer is. Putting off all that nice eddy current and stuff. This is so much cleaner that I can get an accurate reading on this transformer. 248 volts. This is what I got coming in from the wall is 241. Okay. Let's see here. All right, we're all unlocked and now I can do our measurements. We've got 2,516. 2,516 plus. This is tough, isn't it? 374 volts. 2,809. And that's marked for 2,600 under load. The other thing is I had a gentleman call me once. I said, hey, BBI, I got this new transformer, I keep hooking it up, and it pops a breaker every single time. I said, well, how do you have it hooked up? He goes, well, I've got the green wire going to 0, and I've got the white wire going to 220, and I got the black wire going to 230. That puts me on the 230 tap, right? And all I could do was start chuckling. I was like, nope. What he had done is he had literally shorted all three of the terminals together by attaching the ground lead. When you see a transformer like this, it's got 0, 220, 230, 240, 0, 220, 240, or just a straight feed, fixed primary, fixed secondary. They're thinking of the sum total of the two voltages in the transformer. So you float the ground, hook it to the body of the transformer where it needs to be. Okay. So this one's right on the money. Now the thing is I think is odd is if you go to Harbuck today and you go and you look at their catalog, for $699 you can get this same transformer, but it's a 2 amp. This is a 3 amp. Remember, unless it's got a data tag on it, its value drops significantly because nobody knows what it is. Just because you get the label printer out, it's great for you, but that doesn't help you with any resale value. Data tags. Data tags. Especially this right here. Continuous duty cycle rating. Yeah. I can't come back to these guys enough. As a buddy that turned me on to them, he told me, he goes, they're my best kept secret in radio. And I'm like, right? He goes, but in the same breath, I want you to go out and share the prophecy. Okay. So I'm doing that. I've made good relationships with those people. They've taken good care of me. They've sold me some awesome products. Well, let's muscle on here. Let's get on to the next one. I always said EPD makes a dangerous transformer. And the reason I say that is because their iron is so quiet when it's running. You can barely hear this puppy running. Just barely. Now let's check our primary. Ooh, that's way off. Has something to do with the placement of the meter. Oh well, we ain't gonna worry none about it. Secondary, 3,248 plus 2,733. 590. It's marked for 520, and I probably read more accurately since I would need to bump that up to the 240 because that's what I'm actually putting into it. About 230 something, 240 volts. And if we were going to take that and then we times that by 1.145, they get me 6,840 volts post rectification at 4 amps continuous duty. Everybody seen how I did that? You take your secondary tap value of 3,000, let's say on this transformer, and you times it by 1.145. So 3,000 times 1.145. 1.45 equals. That's post rectification. That's what you're going to see after you rectify it through your diode string. Same thing over here. We'll take 2,600 times 0.145. It gets you 2,970 volts, which would be perfect for a bunch of Z's. Or on the mid to low range tap, up to what? You could probably run a couple of 800s easily off that, or 1,500, 2 of them, off this one transformer. Now, if you looked and you seen what's on the inside of an SP220, you'd see the transformer is about this size. What do I got that I can throw up in there that'll give us an idea of scale? Ooh, I know. Throw a dual bird line section up there, or a 3500Z. Big boy parts. You could easily run off of this 2 3,000s, a 5,000, 6,000, or a 10 off this one transformer. Yep, this is a beautiful piece of iron. Boys and girls, I hope you enjoyed the show and tell time. Hopefully it was a little bit educational for y'all. My name is BBI, and I'm going to get over here and keep playing because I want to get done with this and move on to some other projects. I got a video I got to shoot for my buddy Mr. Jefferson on his 32 pill I just completed, which I think you're all going to enjoy. Come check us out, www.amps.com. Yes, I also do AC. I just only build them for friends. Come find me on Pal Talk. Keep your dick on the ice. Real quick, sorry. Y'all thought the video ended? No. Let's talk about EPD. I've owned probably 100 pieces of iron, if not more, from these guys for different products. I'm here to tell you that the quality of the construction. I mean, just look at it. The quality of the construction. The care to which they put into whatever it is that you ask them to design. This transformer was custom designed for me. I called them and had them build this to my specifications. This wasn't just something I ordered out of a catalog. This is all they do. They are the backbone of Tentec Amp, Ameritron Amp, Amp of America, and a bunch of other amp companies. A bunch. If you see this name on a transformer, it's worth every penny. The quality between this and this is staggering. Absolutely staggering. Once you get to running it, you'll understand why. Hell, the little 100 amp transformers that I put in all them amps that I build, that run on 220 and stuff, I can put almost double the amount of current load on those transformers, and they don't budge. They're over-engineered, they're over-designed, they're overbuilt, they're over-constructed. That's why they get the money that they get for them. When you call them and you tell them that you want a transformer, they're going to automatically assume that you want it to be continuous duty cycle, which means turn it on, run it out to that load, and stand on it for eternity. Whereas us as radio operators, we normally do about a 30% duty cycle. The amount of iron and copper that it takes to make a continuous duty cycle transformer is significantly different than what it takes to make a 30% duty cycle. These are already assumed that you're going to run a 20 or 10% duty cycle upon them. It's the way they were designed. You can tell by the data tags. And they have a tendency to get warm as soon as you put a long load on them. It's because of the way they were designed, but they don't have that represented on the data tag. It's a continuous duty cycle transformer. Just food for thought. I endorse EPD. I stand with Michelle and Peter until the end of time. They're good, honest people. They build an awesome product. They do it for a reasonable price, but you get exactly what you pay for in this business. It's like everything else in radio. If you shortchange yourself and you decide that you're going to go with your buddy's transformer that came out of a pole peg. Pole peg transformers are designed to be submerged in oil for cooling. The core on this is bigger. The wire is not made of aluminum. It's not aluminum coated either. It's not aluminum wire with a copper coat on it. Pole pegs will work for a short period of time, but they're dangerous. They get hot, they'll catch on fire. They melt down, they short out, they burn your house down. Or they're constantly dripping oil out of them because, well, we're submerged in oil. Not my thing. Pole pegs are not my thing. This is a step up from a pole peg, and this is a significant step up from that. Just saying. Do as you wish. Be safe. Don't electrocute yourself, please, for the love of God. If you don't know what you're doing, you're not comfortable working with high voltage, you don't have 10-to-1 reduction probes, you don't have hot gloves, you don't have the proper equipment, you're going to kill yourself dead in a doornail. So I show this to you, and I beg of you, please, please, please be safe. Okay, I'm off my soapbox. I'll see you boys. I gotta go play.